Hello, Honors Algebra. This is going to be the last video for a new topic in Chapter 12. Mr. Lawrence here, of course. And after this lesson, you're going to be able to say, I can calculate the midpoint of a line segment. All right, let's just get right down to this. I've got this line segment AB drawn. Okay, notice it doesn't have arrowheads because it's only a segment. I know the coordinates of A are at 2, 1, and I know the coordinates of B are at 10, 7. Now, I'll bet most of you could just come on over here and find the approximate middle and be pretty confident that you're finding the middle. And I'll tell you what, I'll call that midpoint 1. And I'll bet the coordinates of midpoint 1 are very easy for you to find. Looks like it's going to be at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 6, 4. Now, do you notice something about 6 and its relation to 2 and 10? I mean, if this is 2 right here, and this is 10, how long is that distance? 1, 2, 3, 4, 5, 6, 7, 8 units, of course. And wouldn't that mean I go 1, 2, 3, 4 units over? Now, a similar thing can be said considering the vertical change. Okay, I start here at 1, and I'm going up to 7. That's a distance of 6 units. And so if I go half that, I go 1, 2, 3. And look at that. If I take that green one, and from that orange one, I hit the midpoint, don't I? Well, you're not going to always have a graph or something to determine this by, but it's really pretty easy if you know how to get 6 from 2 and 12, 2 and 10. Almost gave the answer away. Yeah, I'll bet some of you are thinking right now, well, hey, if I go 10 plus 2, I get 12, and then I divide it by 2, I get 6. And if I take 7 plus 1, I'll get 8. Cut that in half, I'm going to get 4. And the midpoint was at 6, 4. What did we do? Well, we just average the x's, and then we average the y's. That's all you have to do. Now, textbooks make it more complex. They give you this formula, and if you know you're not a math person, sometimes it looks a little bit intimidating. But all this formula is saying is average your x's and average your y's. You're taking two x's, adding them together, dividing by how many there are. Taking two y's, adding them together, dividing by how many there are. There you go. All right, let's try it and see how it works. This time I'm looking at segment CD, which you can't see, it's not drawn in, but I'm going to go ahead and try to find the midpoint of CD. So I'll call this midpoint CD, and I'm going to average my x's. So I'm going to go negative 7 plus 4 divided by 2, which is going to be negative 3 divided by 2, which is negative 1.5. I'm betting that the x-coordinate is going to be at negative 1.5. And then the y's is going to be 3 minus 1 divided by 2, which is going to be 2 divided by 2, which is 1. So I think the midpoint of segment CD will be at negative 1.5, 1. Well, let's put that segment in and see if that is indeed the case. Just so happens I have a segment handy right here, CD right there. And I'm going to see if I can just kind of find the midpoint as easily as I did on the last one. Let's see here. Well, not quite as easy because it's not going through. So let me go to the coordinates, negative 1.5 and then 1. So it's going to be right there. Hey, that looks like it's about the same distance. You know, we could test it using the Pythagorean theorem idea. Let me get a different color here. Now, in fact, let me use the line segment because that'll be a little bit easier. So if I go down 2 and then over 1, 2, 3, 4, 5.5, right? So let me put those in. So if I was going to do a Pythagorean theorem on this, I would have A and B to be 2 and then 5.5, right? Well, if it's truly the midpoint, then when I go do a Pythagorean theorem on the other half, I should have the same dimensions. So let me do that one. So it looks like I'm going to go down 1, 2, and then I'm going to go over a half, 1, 2, 3, 4, 5. So I go down 2 and over 5.5. And so the triangles that I drew there are exactly congruent, and therefore I can assume that their hypotenusa are congruent. Excuse me. And so therefore this point here must in fact be the midpoint. Sorry about that. I didn't want that big bulky arrow to show up there. I wanted instead to draw this point right here. That's my midpoint. Okay, so this averaging thing works. So now to find the midpoint of FG, I'm not even going to draw the segment. I'm just going to average my x's. So I'm going to get -6 plus -3. I'm going to divide by 2. And then to get the average of the y's, I'm going to do -7 plus -2. And I could just write -2 if I wanted. And I'm going to divide by 2. Okay, so this is going to be the midpoint of FG. And so that'll be, what is that, -9 over 2, which is going to be -4.5. And then I'm going to have another -9. Oh, it's going to be another -4.5. That's interesting. If I draw my segment in, well, here, I'm not going to draw my segment. Yeah, let's go 1, 2, 3, 4.5. 1, 2, 3, 4.5. I'm supposing that that's going to be the middle of that segment. And let me draw it in and see. So, well, that sure looks like it's in the middle, doesn't it? Okay, let me make that a little bit bigger. And if I look to do a Pythagorean theorem thing, I'm going to go what? Over 1.5, and then up 1, 2.5. So 1.5 and 2.5. And then if I go here, I'm going to go over 1.5, 1.5, and then down 1, 2.5. And there you go. I get a congruent triangle, so I can assume that the hypotenusa are congruent to each other, and therefore this point right here is in fact the midpoint, and that's M midpoint of F segment FG. Okay, that's it for the lesson. All you're doing is finding the average of the x's and the average of the y's. Should be real simple stuff. Mr. Lawrence signing off. Have a good night, everybody.